Welcome to qnawire.
Elliptical orbit when it's a distance r initial, 2.5 times 10 to the 11th meters from the sun. And then we want to find its speed when it's moved to a closer distance of 5 times 10 to the 10th meters. So to do this, since this is an elliptical orbit, we'll need to use conservation of energy rather than using our equation for velocity in orbit, since that only applies to circular orbits. So we'll set up that E initial equals E final. And there's no external forces acting here, so we have no external work. So we just have then our initial potential energy plus our initial kinetic energy equals the final potential and the final kinetic energy. So our initial potential is negative g, gravitational constant, then mass of the sun, little m for mass of the comet, then divided by that initial distance. And then we have 1/2 mass of the comet v initial squared. And that equals pretty similar terms. So negative g mass of the sun, mass of the comet over that final distance and plus 1/2 little m v final squared. So the mass of the comet cancels out everywhere. And we can get then v final by itself. So we'll come up here for that. So we'll do 1/2 v final squared, and that should equal 1/2 v initial squared, and then we'll have minus g mass of the sun over our initial and plus g mass of the sun over our final. So we'll factor out the g times mass of the sun and move this 2 and take the square root. So we should get then that v final equals the square root of v initial squared, and then we'll have plus 2g mass of the sun, and that'll be times 1 over our final minus 1 over our initial. And so now we have all those values, and we can find then that the final velocity will be 6.8 times 10 to the 4th meters per second.